Good morning, student. Today we are going to study the Jablonski energy level diagram, in which the topic fluorescence, phosphorescence are also included. Now let us see the diagram of Jablonski energy level diagram. Listen, what happened in this? First, here is a single state. What is here? Here is a ground state. What is it there? Ground state. Assume is a ground state. And in this ground state, when the photon or electrons when an electron accepts a photon, it get excited. What it get? It get excited to first state or second state or many. Okay. Then if the photon is fall on these electrons, what happen? It get excited to the single state 2. Okay, from single state 2. And here the electrons, it remains for some time. Okay, here the electron remains some times, and the electrons gets fall into the single state first. This process when the electron gets fall to from second state to the first state, it is called as interconversion. What we call that? Interconversion. In detail we will also see what is meant by IC. Okay, in detail. Now, what happens when the electrons falls from the second state to the first state? That distance is known as internal conversion, or that process is known as internal conversion. Now, these electrons get to the single state, and from this single state, what happens? It falls to the ground state. Directly falls to the ground state, and while falling from single state to the ground state, what happens? Some energy gets emitted, and this emission of light is known as fluorescence. Okay, this is why this fluorescence occurs when it falls down from single state to the ground state, when the electron falls down to the ground state. But if the electron is directly transferred from single state to the triplet state, okay, this transition is known as intersystem crossing. What we call intersystem crossing. From single state to the triple state, when the electron gets transferred from single state to triple state, that crossing is known as internal system crossing. Okay, when the single state electron gets passed into triple state, what happened to this single state? What happened here also? From triple state now the electron falls to the triple state number 1. Okay, and from this triple state number 1, it falls to the ground state. And when the electron falls from the triple state to the ground state, what happened? Here also some energy gets emitted, and this emission of light, or this emission of energy, photons or electrons, that is known as phosphorescence. What we call that? We call that phosphorescence. Okay, understood? All of you understood the Jablonski energy diagram. This is about the fluorescence and phosphorescence. Together we call this the luminescence. What we called it together? Luminescence. Let us study some what is meant by luminescence. That is energy level of luminescence transition. Now look at this. Single excited state. Now listen here. From here we find in the value of lambda means wavelength. Okay. Now from the ground state, the electron gets shifted to the different level. So from single state to ground state to the single state. This is for S2 step. This is for S1. Okay. If the electron get falls in this, what happen? It is considered to be lambda 2. And when it get falls from the single state once, okay, then it is wavelength is lambda 1. Okay, it is lambda 1. Now what we consider that this is an vibrational relation. What we call it, this is an vibrational. Vibrational relation means it is levels of single state. It is a levels of single state. This is an intercrossing, and from which the electron gets falls to the ground state, that is in quenching. That is known as quenching. This is triplet state, triplet excited state. This is single excited state. These two are single excited state. Now let us see the details the what is meant by internal conversion, what is meant by intersystem crossing, what is meant by triplet. Okay. Deactivation processes. The molecule can rapidly dissipates excess vibrational energy as heat by collision with solvent molecule through vibrational relaxation process. Second, EMR. This deactivation process is followed by interaction conversion, intersystem crossings, quenching, fluorescence, and phosphorescence. Let us know about what is meant by internal conversion. The term internal conversion describes intermolecular processes by which a molecule passes to a lower energy electronic state without emission of radiation. These processes are neither well defined nor well understood, but it is apparent that they are often highly efficient because relatively few compounds exhibits fluorescence. Intercrossing system. Intercrossing system takes place from excited single state to excited triplet state. Transition occurs between the singlet ground state to an excited state, that is, electrons are antiparallel and paired, and electrons are parallel and unpaired. Return to ground state is much slower process than fluorescence or phosphorescence. Emitted radiation is of an often longer wavelength because the energy difference between the two is small. Vibrational relaxation. This relaxation process is so efficient that the average lifetime of the vibrationally excited molecule is 10 raised to power minus 12 seconds or less a period, significantly shorter than the average lifetime of an electronically excited state. External conversion. Deactivation of an excited electronic state may involve interaction and energy transfer between the excited molecule and the solvent or other solute. These processes are called collectively external conversion or collisional quenching. Evidence for external conversion includes the marked effect upon fluorescence intensity exerted by the solvent. Furthermore, those conditions that tends to reduce the number of collisions between particles generally leads to enhanced fluorescence. Fluorescence and phosphorescence. Fluorescence and phosphorescence are the type of molecule luminescence method. A molecule of analytes absorbs a photon and excites a species. This emission spectrum can provide qualitatively and quantitatively analysis. Thanks for watching. Please like, share and subscribe my channel. In the next video, I am going to share about what is meant by quenching. Till then, goodbye. Take care. Thank you for watching.